Hello everybody and welcome back to Handmade Rooms, where we code graphics applications from scratch in Odin. We haven't been able to do too much graphics coding until now because we've been focused on the platform layer. So I'm pretty excited for this session where we can actually do some more graphics programming. So we'll draw some stuff, we'll draw some rectangles, and it'll be fun. And we'll finalize some panning and zooming stuff. If you haven't watched the recent video that I made about transformations and coordinate system and panning and zooming, you probably want to check it out because we'll be basically doing what I described there. There's also another video that I did about drawing rectangles. We'll basically draw rectangles the way I described there. So you might want to check those two out. Anyway, so for this episode, for this session, the first thing we're going to do is a bit of cleanups from last session for our platform layer, and a little bit additions to the functionality for our interaction. And we want to do some leftover stuff that we had for the input for the keyboard. We want to make it platform independent, and we'll see how to do that. Okay, first of all, the last part that in the last session was pretty gnarly with the whole raw input here. So we may want to do like a little bit of cleanups here. So let's see what we're actually doing here. Just a small quick recap. So this function here, get raw input, that we're calling it twice. So the first time we're calling it, we're not providing any pointer to our input data. And when we're doing that, what ends up happening is that we're passing a pointer to this raw input size. So it gets filled if there is some raw input for us to query, for us to use. So it gets set to some non-zero value if there is something like that. And the result has to be 0 in that case, so we don't have any errors. So that's the first use of get raw input data. Second use of get raw input data, everything the same except that we are providing the raw input, pointer to a raw input, so we are expecting it to get filled, and we are passing the pointer again, and this time it's actually going to be using that size. So and then the result that we're going to get, if we do have raw inputs to query, is going to be the size that we got the last time. It's kind of a confusing scheme here for Windows, but that's how it works. Okay, so we basically have some repetition here, and we basically want to simplify what we're looking at here. So what we really would have liked to have, if we had like a nicer Win32 API, is just like ask, do you have any raw input data for our mouse? So we would have liked to do something like if has raw input or something like that. We could instead just say, hey, if the mouse moved. So you say if mouse moved, and just a procedure that's called like that, and then we do what we ended up doing at the very end, which is this. Now currently we won't be able to do that because this is actually the name that we gave to our handling. So let's go back to input and see what's going on. So we have set mouse button state, and we have set mouse wheel, and we have mouse moved. So first of all, we can change this to just set mouse can do it set mouse delta or something like that, because we are dealing with a relative movement. We can just say set mouse movement, actually. Movement, yeah, that'll work. Right, we don't need to print it anymore. You saw that it works. So let's go back here, and we'll just do that. Okay, so if the mouse, if I can spell mouse, moved, and you can see that the only thing that we're actually needing in this entire scheme is our L param, right? So it'll be like that. So let's start fleshing out what a procedure like that is going to look like. We can do it here and then we can move it. Okay, so we have this, and it's a procedure, and it takes an L param, which is an, let's see here, an L param. Come on. Alright. And it's going to return a bool, right? So we want to check on it. So let's just start inlining all of this, and for this case we'll do, yeah, so if there has been a movement, then we'll just do like return true, right? Let's move this inside here, and in all other cases we want to return false. Right, we haven't changed anything else here. We will need to do the using up here as well, because we want to just access it like here. Okay, so first of all, let's see that this works. We'll just move this out of here to make it cleaner, and we'll just say put it in here. Alright. Don't know why it didn't go all the way. Okay. Yeah, this looks alright to me. Let's see. So we're doing like this, and it's working, right? And we are having all of our relative input, right, even as we go off the screen here, and I continue to scroll, continue to move the mouse. Alright, that's working, but we can still make it a little bit cleaner. There's a lot of mess here. So first of all, we have this repetition here with this call, right? So we can just let's see, can have some procedure, and we call it just get raw input, and it is going to, we can make it like inline, so it's like as if we didn't actually extract it. And the thing that is going to need is whatever it's going to pass in here, which is going to differ, right? So it's going to be like an LP pointer, right? And it's going to be raw input, which is going to be, in this case, going to be our pointer to our raw inputs. So we don't have a conflict here. Yeah. So that's raw input, and it's going to return whatever this thing returns, which is a uint, which is a u32. Okay. Returning u32. Cool. So and you can see it's almost always doing the same thing with everything except like one parameter. So we can just do, actually we can just have it like do return calling this, right? And in here you can actually do it like have a default of nil, right? Alright, so now in this we're just gonna do, we're just gonna call this guy and without passing anything, right? Because it's gonna be the default of nil. And in the other one here we're just gonna pass in this guy, right? Everything else is the same. Okay, let's see that that worked. Alright, so we're still getting everything working. Cool. Now we're actually, so we're returning a bool. So it's like what we're actually wanting to do. And it's like we're doing some tests on whatever this thing returns. So first of all, we can inline this guy, right? And we're ending it with this, and then we're doing this, and we can inline that here, right? And we're just doing a bunch of ands here. So what we could, we can put this up here. Right. And so it's like if this and this and this and this and this, then return true. Otherwise return false. So we can just say if this and this and this and this and this, and just return that, right? Return, right? This guy and this guy, and this guy. We can just do like that, and this, and that, right? We don't need to return false. So returning if this is 0 and then the size is not 0, and then when we call it with this, it ends up being whatever we got in the size in here, and our type is mouse, and we have any delta movement in either X or Y. That's it. And everything still works. Alright, so we've finished with this cleanup. Now let's do the making our input, making our keyboard platform agnostic. So you see these guys, they're the capital letters, and this ends up being equal to the key code that Windows, like the Win32 API is representing these keys to be. It may or may not be exactly the same in any other platform. So what we want to do is we want to have this decision of which one is representing the W key here. We want that to live in our platform layer. Now it's currently in our application layer. So here's what we can do. We can just say, hey, we have some keyboard. It's in this struct. And we want it to contain like a bunch of keys. So we can just say like a bunch of key codes. One for up and down and left and right. Right? And they're gonna be U8. That's just a key code. And then we can say keyboard, just an instance of keyboard. Alright, and then we're gonna fill those with these values from our platform layer. So let's do that. So we go into here, in our window. Yeah, so like after we initialize our application, we can do like keyboard up is gonna be W, right? Let's do the rest of them. So this is going to be down and left and right. So down is going to be S and left is going to be A and right is going to be D. Right. So now in here we're just gonna do like keyboard up, so the application will have expected this thing to be filled by the platform layer outside before it even got to here. That's fine, we can do that in all the platform layers. Alright, so do down, and this is left, and this is right. Okay, let's see that we haven't broken anything. Okay, so our keyboard is still working. Cool. So we can go one step further to do something very platform specific. Let's say we want to have some key that designate that we want to exit the application. Right? Exit. It's going to be some key code, which in Windows case is going to be VK escape, I think. Let's see. Yeah. And we don't have it, so we need to add it, and I'm going to cheat, and I'm just going to paste it, and you know how to get it already. We'll put it, I don't know, here. Okay, so if we have an exit, first of all, we need to add this here. Right? So, whoops. So if it's exit, what we really want to do is just say that we're not running anymore. So we'll end up getting out of our loop in the same way that we did it in here when it is destroyed, right? So is running equals false. So basically we're gonna do the same in here, right? See, that works. So we're running the application, and then I'm gonna press escape. Boom, our application is closed. Okay, so that's the keyboard. Let's flesh out a bit of what we have in the mouse. So currently we have an is pressed, and it's just a state, and we're gonna end up having to also want to do other things. So for example, I'll just run the application. Let's say we would like to draw. Like when I click with the left mouse button, I want some color to appear behind my whatever my cursor is and persist there. So for that to happen, I need to know the position of where I am at the moment, like the position in the frame buffer, basically, the coordinates in over screen, over cursor in our screen. So and for that thing, I'm only going to be drawing inside of the window, so I don't really care that if I don't get the messages when I'm outside the window. So we actually already have that. It's commented out currently. So you can just use that. What we want to do is like a set the current position, so set mouse position, right? And just pass those. Don't have a set mouse position yet, so we'll add it. So this is set mouse movement, set mouse position. I think we had it last time, and then we moved to the other thing, but we are actually going to use it here, so it's fine. And we basically want to do the same. Of course I misspelled proc. And we want to do like mouse position, called pause. Yeah. Oh no, we have a position. Oh. It's probably a leftover from when we last did it. Let's just call it pause anyway. And for delta, you can call it like delta pause, I guess. Right? And in our application, because I changed the names of the variables, we want to change delta to delta pause everywhere here. Not this delta. This is still the delta of the ticks. So now we won't have collisions, so we can actually do just use mouse. Mouse. Now every time we have like mouse dot, we can just remove it. Right? Alright. It's just a little bit of a cleanup. We actually haven't, so we're printing our wheel, but we haven't actually used it. Yeah, we can do it. The first thing, we can just use that, but let's see that I haven't broken anything. So this is still working. Alright. Cool. But now we were supposed to also have like position, right? Let's just try to print our position. Print pause, right? Because we're using mouse. Right, so we are getting a position right here. Cool, so we can use that to start drawing things. Yeah, before we do that, let's also do the wheel thing, just to get it out of the way. So we're capturing the wheel. We haven't actually done anything, and what we would want to do is, so see, we're having these values. It's incremented, and when I go forward, it's incremented like this, and then it's decremented, and we have it like in steps of 25s, it seems. Right? Okay. So let's say we wanted to do like a zoom. So currently we're using this offset thing, which we should probably just call pan, because that's what it is, right? So let's just rename it to pan. Cool. So and then in our renderer, we'll call it pan here as well. Cool. Haven't broken anything, I don't think. Yeah. And we're also of note, let's see, in our application, yeah, okay, it's fine. Let's see that we haven't broken anything. Cool. So let's do zoom now. So we have a pan, we can do zoom. And the zoom is just going to be, say, another f64, I guess. Could totally be like f32, but yeah, I don't know. Yeah. So we'll say that it's going to be like a factor that we multiply by, right? So its default is going to be actually 1. I don't want to multiply by 0. That will nullify everything. And in here we want to multiply by zoom before we add. Right? So let's see how that looks. So let's see. So first of all, before we try to use the wheel, let's just see how it works if we just do like zoom plus equal 0, 0, 1 or something like that every frame. So as you can see, we're actually zooming out because when we multiply, let's go to our render. So when we multiply, what we're actually saying is like start going to the next, if it's like more than 1, right? If it's more than 1, because we're incrementing, started from 1 and then we're incrementing. So we're saying like go faster, basically, right? Increment this color faster, like more than once in here. So that's what ends up like drawing things smaller because we're incrementing it faster. So it looks like we're zooming out. Okay, so we wanted that to happen when we are actually scrolling out, like moving the mouse scroll downwards. That's when we want that to happen. And in the other case, we actually want to go the other way. So we want to do like, if I decrement this to be like less than 1, then we're starting to zoom in, and and then we quickly going like, okay, let's do it a bit slower, because once it gets to 0, it starts like going backwards, right? So we want this to always be positive. We don't want it to ever get to 0, because once it gets to 0, it, you'll see, poof, flips. Okay. So we had like a black screen when everything's 0, and then it starts like growing on the other way, on the other direction. So let's see how we accomplish that. So we saw a bunch of numbers before for our wheel. Yeah. So in here, let's just draw some numbers. So we could end up with like minus 200, and then minus 150, and then minus 100, and then minus 50, and then 0, and then 50, and then 100, and then 150, and then 200, so on and so forth. Okay, so assume like a wheel, scroll wheel that's at the 0, we want to zoom to be 1, right? Just multiply by 1, just don't zoom at all. For 50, let's say that we're gonna, okay, so what we saw is that going up is actually zooming out. So for like we want to zoom out when we pull our wheel downwards, which will be negative, right? So that's here will be zooming out in this case, and so it's gonna be like, say, 2, and then 4 in here, and then I don't know, 6, and then 8, right? So going negative, we want to map the negative values of our where our current mouse wheel is set to. Want to map those to ever increasing like multipliers. So we want it going down, so we want it to zoom out. So and then in here we're want to do the other thing. So for like a positive, we're gonna want to start decreasing that. We want to have like smaller and smaller fraction between 0 and 1. So this is gonna be like half, and this can be like a sixth or something, right? And this is gonna be like an eighth. Wait. No, this is gonna be a fourth. Yeah. Okay, so let's see how we map from this number, from this row to this row. So say to get half, we do yeah. So to get a half, we do like 100 times 50 divided by 100. That's a half, right? And here is gonna be like 100 divided by 200, right? And here is gonna be like no, sorry, it's gonna be like, here's gonna be 50 divided by 100. Here's gonna be like 50 divided by 200, right? That'll be fourth. Here's gonna be, we can do 50 divided by 300. Yeah, that'll be a sixth. and here is going to be 50 divided by 400, right? So so first of all, if will scroll amount is going to be equal to 0, we want our zoom. We want our zoom to equal to 1. Else, if the will scroll is greater than 0, we want to do a zoom that's gonna be equal to, well, let's see. For this we wanted to say 50 divided by 100. So 100 would be 50 times 2. And here it's going to be like 50 divided by 200, which is twice as this. And here we said 50 divided by 300, which is twice as this. And here we said 50 divided by 400, which is twice as this. So whatever we do is going to be like 2 times whatever we have here, and we want to say 50 divided by that. And I think we need to do like F64. Okay, and then if, well, you can just say else because that's the only thing that's left. If we get a negative number, then the zoom is going to equal, well, let's see how we get here. So 2 is 100 divided by 50, right? Well, if it's negative 50, then to get 100 we need to multiply by negative 2. And then we flip the division. We say we say the 100, which is this times negative 2, divided by 50. And here is going to be 200, which is this times negative 2 divided by 50, right? So it's this, but first thing is we flip the order of the division and we stick a minus sign here, right? See how it goes. Ooh, it's a bit fast, but it's working, right? So this is going in, and you can see we're never flipping because now we're getting more and more and more and more and more dark, but we're never getting to 0, and then we're going way, 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 way out, right? Just repeating. Okay, so now we have our zoom. Cool. And by the way, we haven't actually lost panning. So we can still pan and zoom at the same time, right? Just thought it was worth mentioning that. Okay, so we don't need to print it up. So we have zooming and panning. Now let's do the fun stuff and we start drawing things. So we have a position, we haven't actually used it. So let's just say that, and we have like if mouse buttons dot left dot is pressed, because we have that. Then what we're gonna do, So currently we're only drawing in our renderer. We're only setting the blue and green channel. We're not even touching the red at all. So we can just put a red in the pixel there. So let's go here. So if it's pressed, then all we need to do is, let's use a frame buffer also, using frame buffer, not this one. And our frame buffer is comprised of lines, if you remember, and which line we're going to choose is whatever the position.y, and that'll give us a line, and the pixel that we want is whatever the position.x. That gives us a pixel. So we can say dot color dot red is equal to 0 ff, right? So full red in the red channel, in the pixel wherever we're pressing. And if you notice, we're not actually clearing the red here, so it'll just persist because we're not changing it at all at any point. Okay, so let's just see how that looks. Right, and look at that, I am drawing. Of course, if I move too fast, it starts like having gaps and stuff. And by the way, I can still pan and zoom, because this is kind of, imagine that we're drawing into two transparent sheets of plastic, and we have 3 of those, and 2 of those are the green and the blue, and the third of those is the red, and we're not touching the red at all. We're only touching the red with this guy, but it's currently like 1 pixel, right? It's kind of difficult to see. So let's, instead of just drawing 1 pixel, let's draw some quad in the place that we clicked. So let's do that. So how are we going to do that? So we're going to do whatever we're doing here, what we're going to do it in some nested for loop. So for y in whatever this thing is, to whatever this thing is plus 5, let's say. So this will be like up to and not including, so it's just 4 pixels, 4 pixel wide. So I'm going to do, I'm going to do the same for x. So we're drawing like a square of 4 by 4, and we're just gonna put a pixel there, fill it with red. See how that looks. Can I not do that? Undeclared name x. That's because I forgot to change it. Cool. And look at that. We are drawing. So we can say hell, because it's red, so it's hell. Hello. Hell. Yeah, we're drawing. And it's still, I can still pan it zoom. So let's say hello, obviously. Handmade runes, so we're gonna say like a hand. Alright. That's the little age with the font there. I'm not using a Wacom tablet, by the way, because I don't have one yet. Well, not in here. So hand I think it's like that. It has like a thing here. Handmade, and of course runes. It's gonna be like that. And I totally did not practice that, of course. Anyway, hello, handmade runes. Alright, we're drawing. Cool. Now, let's do some more fancy stuff. So we have a button, we know when it's the left mouse button when it's clicked. Let's say that instead of doing this drawing, we want to draw like a rectangle that starts when we press, and it draws the rectangle until we, like while it's pressed, it starts drawing the rectangle from where we pressed until where we currently are. Just draw a rectangle. It looks kind of like a marquee select with the rectangle, right? So let's see how we can do that. First of all, we'll need two positions. We'll need the position where we pressed originally, and we can like store it here, but no. So this is not like only invoked one time when we start pressing. It'll get invoked every time. So we'll need to track the first time that we get in here. So instead, what we can do, we can just say, let's see, in our mouse is currently, the button only has like is pressed. But what we can do is also say, well, and also say when the mouse is down, we want to have some position, so we can say down pause, right? And it'll be again this guy, some coordinates, and actually, yeah, you can just do chords 2D is this thing because it's getting a bit repetitive, so we can just give it a bit more semantics. Alright, this is the two coordinates and this is the coordinates 2D. Right, cool. So we have chords 2D, we have a down position. So, and when we change our mouse state, we can set it, first of all, we can say set mouse down, mouse button down. I can split it to down and up, that'll be useful. And so we don't need a state, and we can say that we'll be expecting it to also pass the coordinates of the mouse when it was clicked. Okay, and then we can store that coordinate in our button's down position. Del x equals x and y. Cool. And while we're at it, let's do the other way around. So when it's up, going to be true. And we'll have like an up as well. Up. Let's add the up position. So we'll just have 2 position coordinates for each button, for when it was down and then when it was up. So we'll have all the information we can ever expect to need. And we can also say like is released true. Here will be false. And we can say is pressed is gonna be false here. And we want to have an is released. So we can do like that. And down pose and up pose. Cool. So now in our platform layer, let's just push this up. So that's it. Yeah, never mind. So mouse down, mouse up. So now, mouse position, mouse movement. Cool. In our platform layer, we need to change a bunch of stuff. So we already know how to get where we're currently at. So we can just do that. And instead of doing set mouse button state, we can say, because this is going to be down, right? Set mouse button down. We don't need to pass the bool. What we do need to pass are positions, right? And this will be up. Right? Yeah. So this is going to be for the left mouse. Let's just do the right mouse now. And yeah. Cool. So this is going to be down. It's going to be up. And just copy these. And last but not least, we need to do the same for the middle mouse button, just in case we want to use it. And with this, we'll actually, hopefully, be completely finished with the platform layer for good until the end of this series, because this is really getting us all the information we can possibly ask for. Okay. So now we have all the information. We have for all 3 buttons, when it's pressed, when it's not pressed, and the position in each case. So let's go to our application layer and start using that. So we want to draw a rectangle, and if you haven't watched my rectangle drawing video, you should probably do so now, like pause the video and watch it and go back. Otherwise, if you think you know how to do it already, and that's fine. Okay, so a rectangle, we're gonna use the representation that's easy to draw, which is gonna be the min and max. So we just have like a min coordinate, 2D coordinate and the max 2D coordinate. So our main 2D coordinate is going to be, we're going to assume it's going to be our position of the mouse, and the max is going to be whatever the buttons left, down, pause, right? So like we're like click dragging like this. So we start in the middle and in the minimum closest to the origin. Then we drag diagonally to the right and down, and that's gonna be our. So the max is gonna be like. Actually, it's the opposite. So the min is gonna be always wherever we started, like the position that we clicked in, and then the max is gonna be wherever we're currently at. And then we basically want to draw 2 horizontal lines and 2 vertical lines. So our vertical line, let's do a horizontal line first. So it's gonna be like 4, it's gonna be x in min dot x up to max dot x, right? And we'll do we'll draw pixel, red pixel in which line? Well, I don't know. It's gonna be, for the first time, it's gonna be like the min dot y. Right? So that's the first horizontal line, and this is gonna be like second horizontal line, so it's gonna be exactly the same, except here it's gonna be the max. Right? So these are 2 horizontal lines. Now we'll do 2 vertical lines. And the vertical lines, we're gonna loop over y instead of x, going from the min to the max. And gonna be in y, and it's gonna be yeah. So the first one is gonna be in the min x. Yeah. There's 2 vertical lines, and the second one is going to be in the max x. Right, but that's as long as the left key is pressed. The moment we release, there's going to be nothing. Right? Let's see what we get if we do that. Undeclared. Of course, I don't know how to spell. And as you can see, we are drawing a rectangle, but we're drawing all the rectangles in between because we're never clearing it out. Okay, so let's start clearing stuff out. First of all, we can close our platform layer and hopefully never reopen it. Okay, so in our renderer, what we actually need to start doing is just clear out the red channel as well, right? But then we're gonna have a problem because then we're gonna clear it, so we're gonna draw on top of it, right? So it will not gonna see anything because we're drawing on top of it right after So we're actually gonna want to move this after we render. Alright. And look at that, we have a rectangle. But we still have a problem, because if I go like this, then all of a sudden we're not drawing a full rectangle, and here we're not drawing anything. Here we're drawing just these two. And the reason is that we're assuming that min and max are set up this way, but they may not be. So what we actually want to do is say, okay, if the min x is greater than the max x, then do switch them around. So min.x, max.x is equal to max.x, min.x. Right? And the same for y. And look at that, now we can draw any direction we want. And this still works. Cool. Now let's see what if we wanted to actually persist those things. So first of all, for selection we'll probably want to do like value instead of color, and just say 1, because we want just white. Right? The value of 1 is like ends up having the maximum value in both. Wait, what? Ooh, interesting. Okay, scratch that. So we can say color, let's say in render we have some colors, we'll say white, and the white is gonna be a color, and it's gonna be equal to R of full, which is like this, and G and B of full. So this is white color. So in here we'll just do color equals white. That's it. Have an error. Render. Whoops. Alright, so now we have our selection, like marquee or whatever. Cool, so now what happens if we want it to persist? So let's say we're gonna use the right mouse button to do the drawing rectangles that persist. Okay, so in application, yeah, in here we want to do the same thing. Basically we can do that. If the right mouse button is pressed, done with that, then the right mouse button down, we're going to be drawing exactly the same stuff. And we want to make it like red, like before. Right, and our red is going to be just the R. And the rest is gonna default to 0. Cool. Let's just see that works. So we're drawing red and white. Cool. But how do we persist it? So first of all, for persisting, we need to store it somewhere. And we can make a thing that we store. So let's say that we have bounds struct, just gonna be a min and max of chords 2D, right? And we're gonna have like stored bounds, which is gonna be an array of bounds. Let's call it bounds 2D. Stores bounds, and it's going to be a dynamic array. It's going to be initially empty, and each time we draw, we want to edit. So we're going to do append this guy, and we're going to want to append new bounds. So it's going to be like bounds. It's going to be bounds 2D, which is going to be our min max. And actually, we're never going to draw more than one at a time, so we can just put it actually like here. And not initializing it, and then in here we can just do using bounds, and then this min and max are going to be the min and max within those, within this bounds thing. Of course I need to do that, and we'll just add the bounds to our dynamic array. And then well, actually no, because we don't want to append all the rectangles that we're drawing. We only want to do this append when we've released. Yeah. So if the right milestone is released, then we're going to want to append it, and we're going to want to signify that we've actually handled this event. Yeah, so, but in here we're going to have to do this again. Oh, yeah, because it's gonna either be still held or released. So else, if it's released, then we want to do this, and our min is going to be this, and our max is going to be when it went up. Right, so now we've added it in here, and in here, yeah, we can do this here. So before we do all the other stuff, we can just loop over our stored things. So you can say if we have something stored, if the length of the stored bounds is greater than 0, we can just we'll call it current stored bounds in stored bounds by reference do, and then we want to draw. So this is starting to get repetitive, so let's start extracting this out. So first of all, this thing is drawing drawing a rectangle. So let's just extract that out to draw bounds, we'll say. And it's going to be a proc, right? And we say it's going to take bounds, which is going to be bounds called B, and we say using, doesn't matter what it's called, and we'll take it by reference, right? And we're gonna need to do like using frame buffer, right? So this will draw the bounds that we got, and maybe we want to pass in the color. So it's a color, it's going to be a color by reference, by pointer, and we want to put the color in here. Of course we want to do the actual color, not the pointer. Okay, so we have a draw bounds, and now in here we'll just do draw bounds, the bounds, and a pointer to white, right? And in here we're gonna want to do the same, just red. And all the way up here, when we're drawing, we can just do draw bounds, red again. All this guy, current stored bounds, if we have ones. Right. Let's see that we haven't broken anything, and of course we have min and max. Ooh. Using bounds. Redeclaration in scope. We haven't actually done using, I think. So we can do this for here. Stored bounds. Stored bounds. Don't we have stored bounds? Stored. Of course, I mistyped it. Using can be applied a variable of type struct because it's bounds 2D. Alright, what else? Redeclaration of min and max in here. That's odd. Oh, because now we don't want to create new ones, we just want to assign them, because we are using bounds. And here as well. Yeah. Append, stored bounds, ambiguous call, periodic procedure. Wait. This is our bounds. We have a dynamic array of bounds 2D. This is a bounds 2D. Pending. Did I? Oh, okay. There we go. So we're still drawing the whites, and let's see about our red. So we're drawing it, and then when I release, it's still there because now it's being painted, and there we go. We're able to draw basically anything we want, and this still works, by the way. All right. I think this will end our session here. Just one little thing. We could, if we wanted to, start cleaning this up a little bit. So let's just do, whoops. Let's just do that. First of all, this drawing thing really belongs in the render. Resize frame buffer. Okay. So we're drawing it in here. And yeah, we can do like draw horizontal line and draw a vertical line. Let's do that. Draw age line. That'll be drawing horizontal line, and it's going to be a procedure. And let's say it's taking start and end of an I32. And it horizontal line, it means it takes a column also. Yeah. A column. And we need a color like this. And it doesn't return anything. And it could be an inline. And all it's going to do, it's going to do this for X from start to end. And it's I'm not gonna have a using here, so I'm going to do this. And this is gonna be, wait, yeah, horizontal line is gonna be row. Like which row index, and X, yeah, that's fine. And draw the color. Okay, so this is a horizontal line, and a vertical line is going to be the same almost, and it's going to be at some column, and instead of X it's going to be column, and we're going to go over Y in here. So this is going to be drawing a vertical line, and we'll just do capital L here. Now then in here we don't need to using frame buffer anymore, so you can say we're drawing 2 horizontal lines and 2 vertical lines, right? like I showed in my video. So so the start of the first horizontal line is going to be from min x to max x in the min y row, and using the color. The second horizontal line is just going to be the max y. Then the vertical lines is going to be from min to max in y, and the first one is going to be the min x column in this color, and the last one is going to be the same but the max x column. And this should do exactly the same. Undeclared identified man because it's max. Did I do that everywhere? Of course I did. Okay. And look at this. Everything still works. Alright. So this is it. We can draw anything we want now. You can take this to however length you want. You can like make a 2D drawing application. You can draw other things. We can maybe look into drawing other shapes. You can draw filled rectangles. You can play with the width of the rectangles. You can draw circles and rectangles with round corners and stuff like that, and diagonal lines, of course, and stuff like that. We may look into it sometime in the future. But that's it. I hope you enjoyed it. This is all working nicely. And if you like the video, you can hit the like button. If you want to subscribe, if you want to get notified for further videos, you can click the subscribe. That's it. See ya.